100 degrees. Miami has recorded that number exactly once since 1896, on a single afternoon in 1942, and yesterday the forecast came within 1 degree of it. Forecasters put the odds of breaking it at 1 in 10, against a base rate closer to 1 in tens of thousands. The record is still standing, and the pattern that nearly took it down has not moved. By the end of this, you will understand exactly what had to fail for Miami to get this close, and why 1 degree is the least important part of the story. The National Weather Service office in Miami issued a heat alert for South Florida yesterday, ahead of an afternoon forecast to deliver the highest air temperature the city had seen in more than 80 years. The forecast high at Miami International Airport, the city's official climate station, the one that sets the record book, was 99 degrees. Forecasters gave the city roughly a 1 in 10 chance of touching 100. The heat index was forecast to peak near 110 degrees between 3 and 5 in the afternoon, and the local discussion put it in plain language: dangerous heat with no rain and no breeze anywhere in sight. The number that matters in that forecast is not 99. It is 100. Miami has reached 100 degrees exactly once in its entire instrumental record. That day was July 21st, 1942. Between the start of continuous Miami records in 1896 and the end of 2024, the official climate station has never logged a triple-digit air temperature on any other afternoon. Not during the heat of 1998, not in 2010, not during the summer of 2023, when the city ran 46 straight days with a heat index above 100. The all-time record outlived every one of them. Here is the part that should stop you cold. Climatologically, the odds of any given Miami day reaching 100 degrees sit somewhere on the order of 1 in tens of thousands. Yesterday, a forecaster looked at the guidance and put those odds at 1 in 10. That is not a small adjustment to a number. That is the atmosphere doing something it has not done in the working lifetime of anyone who has ever read a Miami thermometer. And the reason that record has stood for 84 years has almost nothing to do with how hot Miami can get. Miami is one of the hardest places in the continental United States to push to 100 degrees, and that is a statement about physics, not about luck. The city sits on a narrow peninsula with water on 3 sides. That geography hands it 3 separate mechanisms that stop the afternoon temperature curve before it can run away, and all 3 are powered by the same ocean. The first one is humidity, and it works in the opposite direction from what most people assume. Moist air has a higher effective heat capacity than dry air. When the sun pours energy into a humid air mass, a large share of that energy goes into latent heat, into evaporating water, rather than into raising the temperature of the air itself. Humid air warms more slowly. That is why the Sonoran Desert can hit 115 degrees on bone-dry air, while South Florida, sitting in some of the highest absolute moisture in the country, struggles to get past the mid-90s. Think about what that means for the record book. The same water vapor that makes a Miami afternoon feel unbearable is the thing holding the thermometer down. The city's misery and the city's record are produced by the same ingredient, pulling in opposite directions. Phoenix only has to be hot to reach 100. Miami has to be hot, and it has to lose its defenses. Yesterday, it lost the first one, because a hot enough air mass will eventually overwhelm even that break. But humidity was never the mechanism doing the most work. The second break is the sea breeze, and it is the one Miami depends on most. Land heats faster than water. By late morning on a typical summer day, the ground across South Florida is significantly warmer than the Atlantic and the Gulf on either side of it. That temperature difference creates a pressure difference, and the pressure difference drives the circulation. Cooler marine air pushed inland off the water, replacing the rising warm air over the land. Florida's shape means almost the entire peninsula is within reach of that marine air, and the effect is strongest right at the coast, which is precisely where Miami International Airport sits. On a normal day, the station that holds the record sits in the most effectively air-conditioned spot in the region. Yesterday was not a normal day. The pressure pattern overhead stalled the onshore flow, and the sea breeze that has protected that thermometer for 130 years either never organized or never made it far enough inland to matter. There is a second problem underneath that one, and it is the more durable of the two. A sea breeze runs on contrast, on the water being meaningfully cooler than the land. Gulf of Mexico surface temperatures have been running at record daily highs this year, roughly 1.8 degrees Celsius above the 1982 to 2011 baseline at points. Seasonal water temperatures around South Florida in August run 84 to 88 degrees, with local readings as high as 92. When the water warms, the contrast weakens. When the contrast weakens, the circulation weakens. The engine that drives Miami's afternoon cooling is being slowly detuned by the same ocean that powers it. 2 breaks down, and the third one is the one that has historically been impossible to defeat. The third mechanism is the afternoon convective cycle, and on a normal summer day, it is the reason a Miami temperature curve looks like a hill with the top cut off. The Atlantic sea breeze pushes west. The Gulf sea breeze pushes east. Somewhere over the interior of the peninsula they collide, the air is forced upward, and thunderstorms build, usually in the early to middle afternoon, which is to say at exactly the hour the surface heating peaks. Those storms do two things. The cloud shield cuts the incoming solar radiation, and rain-cooled outflow spreads out beneath them and drops surface temperatures across a wide area. The heating gets interrupted at the moment it would otherwise be running hardest. On a typical August day in South Florida, that is the difference between the mid-90s and something much worse. Yesterday there were no storms. A high-amplitude upper-level ridge parked itself over the southern United States, and the air underneath a ridge like that is sinking. Sinking air warms and dries as it descends, which caps the atmosphere and prevents convection from getting going. The storms did not fail to form because there was no moisture. They failed to form because the atmosphere overhead had a lid on it. That is why yesterday's forecast discussion read the way it did. No rain, no breeze, no relief. And a heat index climbing into the danger range by early afternoon, peaking near 110 between 3 and 5. Which brings us to the actual anomaly, and it is not the temperature. To reach 100 degrees in Miami, all three of those defenses have to fail on the same afternoon. The air mass has to be genuinely hot. The onshore flow has to stall or reverse, and convection has to be suppressed. Any one of those failures on its own gets you a hot day. All three at once is the only way the thermometer gets to a number the city has seen one time since the McKinley administration. A strong subsiding ridge is the single atmospheric pattern that can do all three simultaneously. It supplies the hot air mass. It stalls the onshore flow through the pressure field, and it suppresses the convection through subsidence. That is the whole story of yesterday in one sentence. This is why a 99-degree reading in Miami is a more interesting number than a 115-degree reading in Phoenix. Phoenix reaching 115 means it was hot. Miami reaching 99 means a system of three overlapping protections built into the geography of the place went offline at the same time. The temperature is not the event. The temperature is the receipt. And the receipt came with a heat index near 110, which is where this stops being a record book curiosity and becomes a public health problem. In a metropolitan area of more than 6 million people, most of whom have no reason to think of 99 degrees as unusual, there is a reason forecasters treated a 99-degree forecast as a genuine alert. And to understand it, you have to look at the last time Miami's heat made national news. In 2023, Miami ran 46 consecutive days with an afternoon heat index above 100 degrees. The streak started on June 11th and ended on July 27th, and it only ended because heavy rain finally capped the heat index at 98. The previous record was 32 consecutive days, set in 2020. That is a 44% jump in a single season, in a record that had presumably crept upwards slowly for decades. During that stretch, the city set 10 daily temperature records and 27 daily heat index records, received its first ever excessive heat warnings from the National Weather Service, and spent 23 days under heat advisories. In May of that year, the Weather Service launched an experimental pilot program for Miami-Dade County that lowered the heat index thresholds required to issue advisories and warnings because the standard national thresholds were not catching the danger in a place that humid. Miami-Dade is the only county in the country where that pilot has been run. Now hold all of that next to one number. Across that entire summer, 46 days, 10 temperature records, 27 heat index records, the first excessive heat warnings in the city's history. The air temperature never reached 100 degrees. Not once. That tells you something important about what the record book actually measures. 2023 was, by every metric that tracks human exposure, the most extreme heat summer in Miami's history, and the all-time high temperature record did not move at all. It sat there, untouched, set by an afternoon in 1942. So when the forecast yesterday came within 1 degree of that mark, the meaningful comparison is not to 1942, it is to 2023. A summer that broke everything except the number everyone watches, and still could not get within 2 degrees of it. That gap between what the record measures and what people experience is the thing worth understanding, and it gets worse the closer you look. 99 versus 100 is 1 degree, and it is also not 1 degree at all. In physics, the threshold is completely arbitrary. There's nothing about the atmosphere that treats the 100th degree Fahrenheit differently from the 99th. In the record book, the threshold is everything. A 99-degree afternoon changes nothing. A 100-degree afternoon rewrites a line that has stood since 1942. The honest way to state what happened is this. The atmosphere got close enough that the distinction came down to rounding, And that raises a statistical problem worth being upfront about. One event in roughly 130 years is not a usable sample. You cannot look at a single 100-degree day in 1942 and conclude that it happens once per century. What you can say is that the distribution of Miami's August maximum temperatures has a hard right edge somewhere near 100 degrees. What nobody knows is whether that edge is a physical ceiling, a genuine limit imposed by the humidity and the sea breeze and the storms, or just an artifact of not having sampled enough afternoons. A second occurrence would start to answer that question. That is the real reason this week matters. There's also a claim circulating that deserves a direct answer because it uses a real number. The argument goes, the record was set in 1942. It has stood ever since, therefore nothing has changed. But a single-day record measures one extreme afternoon. It does not measure a climate. What has moved is the distribution around it, the 46-day heat index streak against a 32-day record, the count of days above every threshold, the overnight minimum temperatures, and the sea surface temperatures offshore. Miami's all-time high standing since 1942, while its heat index records fall by the dozen, is exactly what a warming, moistening subtropical climate produces. The record's survival is not evidence against change. It is a consequence of the same humidity mechanism that makes the humidity increase dangerous in the first place. The related objection, that the airport station sits in a paved environment and the urban heat island is doing the work, is real but bounded. It cannot explain a national record for warmest average overnight temperature across the contiguous United States, or 92-degree water in the Gulf, or a record intensity ridge measured by weather balloon thousands of feet above any parking lot. The signal shows up in data sets with no pavement in them at all, none of which changes the fact that the number everyone is watching is the wrong number. Brian McNulty, a researcher at the University of Miami who maintains a long-running climatology of the city's heat index and dew point, has made the analytical point that matters most in this story. The heat index is the revealing metric, not the air temperature. Modest increases in temperature, combined with modest increases in dew point, produce a large increase in the heat index, which means the air temperature record systematically understates what has actually changed in South Florida. The physiology behind that is straightforward. Your body holds its core near 98.6 degrees, and in heat, it has essentially one tool for shedding energy, evaporating sweat off your skin. That tool works by moving water from liquid to vapor, and it only works if the surrounding air can accept more water vapor. When the humidity climbs, the air's capacity to accept that vapor collapses and the sweat stops evaporating. It runs off you instead. You are still losing fluid, and you are no longer losing heat. That is why a 99-degree Miami afternoon with a 110-degree heat index is, in human terms, more dangerous than a 110-degree Phoenix afternoon at low humidity. In the desert, evaporation still works. In South Florida, the mechanism your body relies on is disabled by the same moisture that is holding the thermometer down. For 20 years, the outer limit of this has been described using a single number, a wet bulb temperature of 35 degrees Celsius, the point beyond which a healthy human supposedly cannot survive extended exposure regardless of behavior. That figure came from theory, and it went untested on actual people for 2 decades. Then a team at Penn State put subjects in a controlled heat chamber, 11 men and 13 women ages 18 to 34 at low activity levels, and measured where their core temperature stopped being stable. The answer came back at roughly 30.6 degrees wet bulb. Vulnerable individuals reach that limit lower still. That is a downward revision of nearly 4.5 degrees Celsius in the number that defines human survivability. In wet bulb terms, that is an enormous correction, and it means the safety margin everyone assumed existed is substantially smaller than advertised. The mortality data already reflects it. Heat kills more Americans in a typical year than hurricanes, tornadoes, and floods combined. The Centers for Disease Control tracked 2,415 heat deaths in 2023, the highest in the systematic record, and 2,394 in 2024. With a cumulative total since 2020 above 9,400. Epidemiologists agree those figures are floors because a cardiac or kidney death triggered by heat stress typically gets coded to the organ, not the exposure. All of that is what a single ridge, parked in the right place, is capable of producing. So it is worth looking at the ridge itself because it is breaking records of its own. The upper level high responsible for yesterday in Miami is not an ordinary summer ridge. Forecast discussion flagged it as likely to set monthly records for the intensity of its high pressure. Read that carefully. Not a record temperature underneath it, a record structure. The atmospheric feature itself is at a record value, and that is the more durable anomaly, because the ridge is what enabled everything happening beneath it. For scale, Earlier this summer, the strongest ridge in the northern hemisphere peaked near 5,998 geopotential meters on August 1st, effectively the 600 decameter mark, a threshold rarely reached over North America at all. Upper air thermal anomalies during this summer's ridge episodes have reached the 99th percentile. The footprint underneath it is continental. No AA guidance placed roughly 30 million Americans under extreme heat risk during this stretch, with another 50 million under major heat risk, 80 million people under one pattern. Heat indices between 105 and 115 degrees have been observed from the Gulf Coast through the southern plains and into the desert southwest, with at least 9 daily maximum temperature records expected to fall over the preceding weekend, and dozens more challenged through this week. The western arm of that same pattern shows you what the ridge does to a place with no ocean at all. Phoenix has now recorded 28 days at or above 110 degrees in 2026. The first 3 days of August all exceeded 110. Forecast highs of 110 to 111 run through Friday under an extreme heat warning, with regional temperatures 10 to 15 degrees above normal for mid-August. Guidance had that record warmth expanding further into the desert southwest today. And Maricopa County has the ledger: 63 heat-related deaths confirmed so far in 2026, with 558 more still under investigation by county health officials. That ratio, roughly 1 confirmed for every 9 pending, tells you how slow and conservative the confirmation process is, and it means the number available during an event is always a small fraction of the eventual total. Same ridge, 2,000 miles apart. One place has an ocean and one place does not, and yesterday the ocean did not help, which points at the part of this that has been quietly rewriting the rules for months. July of this year set the record for the warmest average overnight minimum temperature ever measured across the contiguous United States, 64.2 degrees. That is 3.7 degrees above average and 0.7 of a degree above the previous record from July of 2022. 0.7 of a degree sounds small until you understand what is being averaged. National average records usually fall by hundredths or tenths because averaging across a continent suppresses variance. You need a broad, coherent anomaly, not a handful of hot stations, to move a number like that at all. Beating it by 0.7 is a large margin. More than 90 temperature records were forecast to fall in a single week in mid-July, and most of them were overnight low records rather than daytime high records. Lows above 70 degrees were forecast in Fargo, North Dakota, International Falls, Minnesota, and Portland, Maine. In the current episode, record warm overnight lows in the low 80s across the Gulf Coast are exactly what forecasters have cited as the reason this heat is dangerous rather than merely uncomfortable. The reason is physiological. The human body tolerates extreme daytime heat far better when it gets a recovery window overnight, a period where core temperature comes back down and cardiovascular strain eases. Remove that window and the strain accumulates day over day. Heat deaths cluster in places and nights where the body never gets to reset. That is the mechanism behind Chicago in 1995 and the Pacific Northwest in 2021. And it is why the overnight number is the one to watch. It is also the cleaner climate signal. Daytime maximums are constrained by clouds, convection, and evaporation, all the things that failed in Miami yesterday. Overnight minimums are constrained mainly by how efficiently heat radiates to space, which depends directly on atmospheric moisture. Which brings the story back to Miami, because a city surrounded by 90-degree water does not shed its heat at night either. Every one of Miami's 3 breaks runs on the water around the city. The humidity comes from it. The sea breeze runs on it, being cooler than the land. The afternoon storms are built by colliding sea breezes it drives. Change the ocean, and all 3 change at once. The ocean has changed. NOAA's Climate Prediction Center has an El Niño advisory in effect. The weekly Niño 3.4 index stood at plus 2.6 degrees Celsius as of August 10th. The official 3-month index for May through July came in at plus 1.39. Forecasters put the odds of this event persisting and strengthening through the coming Northern Hemisphere winter at 97 to 99%, and NOAA gives it 90% odds of reaching strong or very strong status across August, September, and October. Read that timeline again, because it is the uncomfortable part. This is not the peak of the event. This is the leading edge of it. The heat currently breaking records across the country is happening while the forcing behind it is still building. Around South Florida, the numbers are already outside the historical range. Gulf of Mexico surface temperatures have been running at record daily highs, roughly 1.8 degrees Celsius above baseline at points this year. Seasonal water temperatures in August run 84 to 88 degrees, with local readings up to 92. In July of 2023, a sensor in Manatee Bay near Everglades National Park recorded 101.1 degrees. a candidate for the warmest seawater ever measured anywhere, though it came from a shallow, murky, restricted body of water and its record status is still contested. That same summer, a coral restoration site off South Florida recorded 100% mortality. NOAA notes that reef corals generally thrive between 73 and 84 degrees. The same ocean state is producing one more effect that almost nobody reads as connected. The 2026 Atlantic hurricane season has produced 2 named storms, Arthur and Bertha, and 0 hurricanes through early August. NOAA raised its probability of a below-normal season from 55% to 75%. El Niño strengthens the upper-level westerly winds over the tropical Atlantic, which increases vertical wind shear, which tears developing storms apart. A quiet Atlantic normally reads as good news. In this case, it is the same system that is holding the heat in place, and in South Florida, a tropical system is one of the few things that reliably breaks a heat pattern. So the ocean that built Miami's protection is now the reason the protection failed, which leaves one question for the next few days. The first thing to watch is whether the record actually falls. Yesterday's 10% probability applied to yesterday. The ridge is forecast to hold and expand westward, which means today and tomorrow both remain live for South Florida. The document that settles it is the daily climatological report issued by the Weather Service office in Miami, the routine product that publishes the official high for the station. If 100 degrees appears in that report this week, it will be the second time in 130 years, and the statistical question about whether that right-hand edge is a real ceiling starts to resolve in a direction nobody wants. The second thing to watch is the ridge verification. The measured heights against the monthly pressure record will not be published until after the pattern breaks. If it verifies, the more important record from this week will not be a temperature at all. The third is the Maricopa County backlog. 63 confirmed heat deaths against 558 under investigation is a mid-season snapshot, and in prior years, those numbers converged substantially by the time the season closed. That conversion rate is what reveals the true cost of this summer. And the fourth is the ocean. NOAA gives 90% odds that this El Niño reaches strong or very strong status by October, and the September index update is the checkpoint. If it strengthens on schedule, the water around South Florida is not cooling off in a hurry, and the sea breeze does not get its contrast back. Here is what to take away from all of it. Miami's 100-degree record has stood since 1942, not because the city has never been hot, but because the city has always had a way to stop itself from getting hotter. The water made the air humid, and humid air resists heating. The temperature difference between land and sea pulled marine air on shore every single afternoon. The colliding sea breezes built thunderstorms that shaded and cooled the surface at the exact hour the heating peaked. 3 separate breaks, all powered by the same ocean. Yesterday, all 3 were offline at once. The real question is not whether a thermometer at an airport reaches a round number on a Tuesday or a Wednesday afternoon. The question is, what happens to a city whose entire climate identity depends on the ocean cooling it every afternoon when the ocean stops? We will be tracking this one as it develops.